Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 13, the graph of a linear equation in two variables. Okay, so classwork exercise starts out with this number 1. It says find at least 10 solutions to the linear equation 3x plus y equals negative 8. What we want to do when we're solving for values is choose values for the variable that has the coefficient that's not 1. It makes it easier. So y has a coefficient of 1. This is 1 times y. So it's easier to calculate values for y if we focus on x first. I always like to start with 0. So if I plug in 0 here, then it's going to be 3 times 0 plus y equals negative 8. And then 0 plus y equals negative 8. So therefore y equals negative 8. So I get my y value of negative 8. Okay, so I'm going to continue in this fashion. I'll change colors on each row so you can see the difference because I'm taking up a lot of space here. If I plug in 1, then it is going to be 3 times 1, okay, plus y equals negative 8. 3 times 1 is 3, plus y equals negative 8. Subtract 3 from both sides, and I get y equals negative 11. So there's my value, negative 11. Okay, so now I'm going to do one more above 0. I'm going to plug in 2. And now that's going to be 3 times x, which is 2. 3 times 2 plus y equals negative 8. 6 plus y equals negative 8. And when I subtract 6 from both sides, negative 8 minus 6 is negative 14. So now I have negative 14. Now if I'm graphing on the coordinate plane, I've got the coordinate plane here, I'm going 0, negative 8, 0, negative 11, 0, negative 14. Well, we're getting pretty low. I want to find values up here as well, and possibly values in between. So I'm going to continue, but I'm going to go the other direction now. Now let's go make my x negative. So now I'm going to switch to negatives. Negative 1. So then 3 times negative 1 plus y equals negative 8. So positive 3 times a negative 1 is negative 3 plus y equals negative 8. Now what's going to happen here is we're going to add 3 to both sides. So when I add 3 to negative 8, I get negative 5. So I'm moving up. So that's the point negative 5. Well, negative 1, negative 5, actually, if you want to call it a point. I'm going to continue to the left on the x-axis. I'm going to choose negative 2. So 3 times negative 2 plus some y equals negative 8. 3 times negative 2 is negative 6 plus y equals negative 8. And negative 6 added to both sides would give me y equals, or add 6 to both sides, I should say, and y would be negative 2. So I'm still haven't gotten up to the x-axis here. I'm working my way this direction, but I need to keep going. So now I'm going to choose the point negative 3. And when I plug that in, I get 3 times negative 3 plus y equals negative 8. Negative 9 plus y equals negative 8. Now I'm adding 9 to both sides. That should be a y. So when I add 9, I get y equals, and negative 8 plus 9 is 1. So now I'm at the point negative 3. So this would be negative 1, negative 2. Here's negative 3. 1 would be up here. So now I've crossed over into the second quadrant. And I'll do another one. So negative 4. 3 times negative 4 plus y equals negative 8. Negative 12 plus y equals negative 8. Add 12 to both sides and y equals 4. Okay. They said to find at least 10. We've done 7. Okay, so I'm going to stop there with integers, and now I'm going to pick values in between. What happens if I choose negative 1/2? And what happens if I choose positive 1/2? And what happens when I choose positive or negative, how about negative 1.5? Or negative 3/2? So let's do those 3, and then that'll be our 10. Okay, so if I take 3 and substitute in negative 1/2 into my equation for x, and I add y to it, I get negative 8. 3 times a negative 1/2 is negative 3/2 plus y equals negative 8. Add 3/2 or add 1.5 to negative 8, and I'm at negative 6.5. Okay, so negative 1 was negative 5, and negative 2 is negative 2. Negative 1.5 should be in between these two, so did I do this correctly? This is 1.5. 8, 7 minus negative 6 and 1/2. Okay, so negative 1/2 is between 0 and negative 1, so my answer should be between negative 8 and negative 5, and it is. Okay. So now we're going to continue. So it doesn't matter what order we do these in a table, as long as we graph them correctly when we move over to the coordinate plane. So now I'm going to multiply 3 times 1/2, and I'm going to add y and get negative 8. 3 times 1/2 is 3/2 plus y equals negative 8. And then when I subtract 1.5, I'm going to get negative 9.5. So this is negative 9 and 1/2. At the point positive 1/2. So it should be between positive 1 and positive 2, and negative 9.5 should be between 0 and 1, I'm sorry, between 0 and 1. So 0 was negative 8 and 1 was negative 11, and negative 9.5 falls between those two. And then finally negative 1.5. 3 times negative 1.5 is a negative 3/2 plus y equals negative 8. This would be negative 9/2 plus y equals negative 8. And y equals, adding 9/2 is 4.5. So if I add 4 to negative 8, I'm at negative 4. And add another half, I'm at negative 3 and 1/2. Okay, so there's my 10 points. Okay, so now that I have my 10 points, I'm going to graph them. So I'm going to plot the point 0, negative 8. And I'm using a online graphing calculator, if you will, and it's called geogebra.org, just to give them credit for their site. And I'm going to input my points. So all I have to do is click here and choose parentheses and do 0, negative 8. And it will put the point on the line, or on the graph. So here's the point 0, negative 8 right there. And then I'm going to plot the point 1, negative 11. Okay. Okay, so now I'm going to do parentheses again. 1, negative 11. And now if I move my graph so I can see it, there's the second point B. 1, negative 11. Now I'm going to plot 2, negative 14. I'm going to just keep doing this. 2, negative 14. So that's over 2 down 14. Okay, so there's my third point, my C. And when I hover over this, it nicely shows me what my coordinates are. So 1, negative 11 is B. There's 1, there's negative 11, so there's my B. So this is A, B, C, and we're just going to continue. So parentheses, now we're at negative 1, negative 5. So when I plot that, it's right here. And when I hit the return button, it's going to label that D. So that's the point negative 1, negative 5. So I didn't go in order on my table, so therefore the points are not going in order on my graph. I went to the right until I was going too low, and I decided to go the other way on the x-axis, and now we're increasing on the y. Okay, so now I'm going to plug in the next one, negative 2, negative 2. So parentheses, negative 2, negative 2, return. So there's E, negative 2, negative 2, which is this one here. So while I'm at it, I should probably label these so you know which one's which. This was A, this was B, this was C, D, E, and then you can see where they are on the graph. And now I'm going to do F, and that's going to be negative 3, 1. So negative 3, 1, return, and there is F. And now G is negative 4, 4. Okay, so now I'm up here. Now I'm going off the screen, so I'm going to move down like this so we can see where we're headed. Okay, so this was G, and H will be negative 1/2. Okay, so actually I don't need to, actually right there should be okay for now. So as you can see, it looks like it's a straight line. But what is happening between our integer values? That's all we've done so far, are integers. So my graph could possibly curve down here and then back up and curve around. It may not be a straight line, so we want to choose values in between to see if it consistently stays on that straight line. So now we're going to plug in 1/2, and I haven't done H yet. So now I'm going to plug in H, which is negative 1/2, and I'll do 0.5 for 1/2, comma 6 and 1/2, which is negative 6.5. I'll just do decimals just to make it easier to plug in here. And see where H fell? Still right on that straight line. H fell between A and D. So A was 0, D is negative 1, and negative 1/2 is between 0 and negative 1. So now we're going to do I, and it's 1/2 comma negative 9.5. So I'm going to do the input as 1/2 comma negative 9 and 1/2. And that fell between A and B. A is 0, B is 1, 1/2 is between 0 and 1. Negative 1 and 1/2 will be J. And negative 1.5 is between negative 1 and negative 2. So my answer should be between negative 5 and negative 2. So keep that in mind. And we're going to do negative 1.5 or negative 1.5, comma, negative 3.5. And hit enter. And that was J, and J is right here. And it fell between E and D. So D and E was negative 1 and negative 2, and sure enough, there it is. So as you can see, when we choose fractions in between, it's still on that straight line. Didn't mean to move that. Okay, it's still on that straight line, and therefore it is a linear equation. So if I maximize this, we can get a better feel as to what's going on there. All right, so there's all my points. And if I drew a straight line from G to C, okay, so I drew a line on here, and as you can see, every single point we chose is on that straight line. Okay. So now it says, what shape is the graph of the linear equation taking? Well, it's taking the shape of a line. It is taking the shape of a line. Okay, now we're going to do this again. I'm just going to go through this real quickly, and then I'm going to graph it, and I'm going to work this with you so you can check your work, but I'm going to graph it all while it's paused so that when you come back, you'll just see what the graph looks like all done. So again, for starters, we are going to focus on the coefficient that is not 1, and we're going to choose values for that. So I'm going to choose values for y, and I'm going to start at, oh, I don't know, let's go in order this time. Okay, I'm going to start at negative 5 this time. So when I plug in negative 5 here, I'm going to get x minus, now be careful, we're solving for x now, so we're plugging in for y. X minus 5 times negative 5 equals 11. X minus a negative times negative is positive. 5 times 5 is 25 equals 11. Subtract 25 from both sides, and I get negative 14. So we have the point negative 14 comma negative 5. I'm going to go in order this time. So negative 4. X minus 5 times negative 4 equals 11. X, negative times negative is positive. 5 times 4 is 20 equals 11. Subtract 20 from both sides, and I get negative 9. Okay, choose negative 3. X minus 5 times negative 3 equals 11. x, negative times a negative is positive, 5 times 3 is 15, equals 11. Subtract 15 from both sides, 11 minus 15 is negative 4. Okay, keep going, negative 2. X minus 5 times negative 2 equals 11. X plus 10 equals 11. Subtract 10 from both sides, and x equals 1. Negative 3. X minus 5 times negative 3 equals 11. X plus 15 equals 11. Oh, my mistake. I'm going in the wrong direction. I already did negative 3. So let's erase this and start. I'm going the wrong way. I want to go to negative 1. X minus 5 times negative 1 equals 11. X plus 5 equals 11. Subtract 5 from both sides, and x is 6. 0. X minus 5 times 0 equals 11. X minus 0 equals 11. X equals 11. Okay. 1. X minus 5 times 1 equals 11. X minus 5 equals 11. Add 5 to both sides, and x is 16. Okay, so I'm going to stop right there because I'm getting kind of big numbers here and it's tough to graph them. I'm going to choose some values. Actually, let's graph these first, and then I'll choose a few fractions to verify that even in between integers, it should land on a number line. Okay, so here we go. I graphed all of these points. So A is the point negative 14, negative 5. That's my first one. This is A. Okay, and then I went in order. B is negative 9, negative 4. C is negative 4, negative 3. And 1, negative 2, 6, negative 1, 11, 0, 16, 1. So I'm just showing you that those are what I graphed. Now I'm going to pick a value in between. So let's pick a value between 1 and 6. And actually it's on the y. So let's pick a value between negative 1 and negative 2. So I'll do that in green. Okay. Pick a value between negative 1 and negative 2. And how about negative 1.5? And actually that's my y, so I'm going to move that over here. Negative 1.5. Okay, so now when I plug that in, I get x minus 5 times, and negative 1.5 is negative 3 halves, equals 11. X minus, or plus, 15 halves equals 11. Well, 15 halves is 7.5. Subtract 7.5 from 11, it's 2.5. Okay, so let's take a look at that for now, see where we go. So let me move this over here. And so we have the point negative 2.5, comma negative 1.5. So I'm going to input that. So it's negative 2.5, comma negative 1.5, and graph it. Okay, so there's a problem here. Oh, it's not negative. It's 2.5, so I need to get rid of that negative sign. And that's better. Okay. Or is it? 2.5, comma negative 1.5. Does not look like we're on a number line. I'll draw a line to check it. Okay, so I drew a line through all these points, and here's my h, and it looks like it's up a little too far. So I'm looking at this value here. I wanted negative 1.5, because here's negative 1 and here's negative 2. So I want to be in between those two as far as my height goes. And I think I calculated wrong, so let me check. X minus 5 times negative 3 halves is 15 halves. X plus 15 halves. 15 halves is 7.5. 11 minus 7.5. That'd be a 10, and 10 minus 5 is 5. It's negative, it's 3.5, not 2.5. Okay, so I made a mistake there, so let's fix that. Okay, so change that to a 3, and we should be all good. So this was 3.5, comma, negative 1.5. Okay, so 3.5, comma, negative 1.5. So now I want to go back here, and change that to a 3 and hit enter. And now you see where H is. It is right on that line. So we're going to do that again. How about we pick a point between B and C? C is -3, B is -4, so how about -3 1/2? So it's going to be x minus 5 times -7/2, which is 3.5, equals 11. Okay, so -5 times a -7/2 is positive 35/2, which is 35/2 is 17.5. Let's just change that to a decimal. Equals 11. Subtract 17.5, so 11 minus 17.5 is the same as 17.5 minus 11, and take the sign of the bigger, which is negative, and we're going to get 6.5. So it's -6.5 or 6.5. And I'll make it -6 1/2, or 13/2. So now when I go to plot this, it's going to be -6.5, comma, -3.5. And that was, did I enter that correctly? Okay, I forgot to click here first. Let's do that again. So we're doing -6.5, comma, -3.5. Enter. And there it is, I right there. Okay? So you get the idea here. And if I do one more, how about between C and, how about 0? Let's plug in 0 for Y. Now, actually, we already did. Let's plug in 0 for X. Let's see what happens if I do that. So instead of that being there, I'm going to put it here. So that'd be 0 minus 5y equals 11. -5y equals 11. So therefore y equals -11 divided by 5, which is -2 1/5. So this would be -2 1/5. So if I plug this in as 0, comma, -2 1/5 is 0.2, and hit enter, then J is right here on that line. So all of my fractions fell on that line. So that proves that this is a line. So now it says, what shape is the graph of the linear equation taking? A linear shape, a line, shape of a line. Okay, the shape of a line. Okay, next question. It says 3. Compare the solutions you found in exercise 1 with a partner. Add the partner solutions to your graph. Is the prediction you made about the shape of the graph still true? Explain. So what they're saying here is if you had a partner and they were doing this too, and they chose different values than you did, and they did the calculations correctly, their point should land on the line that you graphed. So I'm going to skip 3. And 4 says compare the solutions you found in exercise 2 with a partner. Same thing. So we're just checking our work there. I'm going to skip those. I'm going to go on to 5. And it says, Joey predicts that the graph of -x plus 2y equals 3 will look like the graph shown below. Do you agree? Explain why or why not. Okay, well, what I would want to do is question a value. So these look like they're linear, sort of, but this doesn't look like it's on that same line. So if I drew a line right here, it looks like those points are all on that line, but this point should not be there because this wouldn't be true if that were the case. And that is the point 0, 0. So if I plug in 0 for x, I want to see where I am on the y-axis. So I'm going to take negative, and I'm going to plug in 0 for x plus 2y equals 3. So -0 is just 0. 2y equals 3, and y equals 3 divided by 2, or 1.5. So my y is 1.5, which is right there, and now it looks like I'm on the line. So with this little squiggly line going all over the place like that, that is not correct. It's more like this. And speaking of squiggly lines, you should never graph freehand like this. You should always get a ruler. And I'm going to be really accurate with where my line ends up. And if I draw a line nice and straight, then those points are on it, and the line is a straight line. Okay, do not freehand lines like this. And even if that point was here, this is a squiggly line. It should be nice and straight like that. Number 6. We have looked at some equations that appear to be lines. Can you write an equation that has solutions that do not form a line? Try to come up with one and prove your assertion on the coordinate plane. Okay. All right, so you don't want a line. In the last chapter, or in this module, we learned that any power of x being 0, or any x to the first power will give us a linear equation. So how about I just say y equals x to a different power, like x squared. Okay, so if I graph x squared, and I'm going to use my program now to save time. If I graph y equals x squared in this program here, then I'm going to open a new one without saving, and I'm going to move this here, and I'm going to input x squared. Let's try that again. X squared. Okay, and there's the graph. Obviously not a straight line, that is called a parabola. So y equals x squared. Any value of x to the power of a number that's not 0 or 1 will not give you a straight line. Okay, that is the end of lesson 13. Review the lesson summary and go do your problem.